Okay, hello again. Let's go over some more parametric equations. I gave you this problem to try yesterday to see if you could model what we had done yesterday with parametric equations for projectile motion. Let's see how you did. All right, use the parametric equations. Again, they gave you these right from the formula sheet to solve the following problems. The left field fence at a baseball park is 400 feet from home plate and 8 feet high. A baseball is hit from 2 feet high with an initial velocity of 150 feet per second at an angle of 25 degrees with the horizontal. The first thing they task us to do is to write a set of parametric equations that model the path of the baseball. The second thing they want to know is this a home run? So usually when you do these questions, they do ask you to get the set of the equations. The horizontal equation, which will be the x equals 1 here, and then the vertical one, which will be the y equals 1 there. They kind of come as a set of two, so we need to make sure that we put both of these equations on our paper. So the first one's going to be our x equals. And remember that this VO is my initial velocity and it appears 2 times in both equations. My VO, I'm kind of looking for the word per because that lets me know that is a velocity, or that's the speed at which I'm going here. Initial velocity even says it right there in the problem. So this right here is my VO, which I'll use for both equations. So x equals 150. And it is x, so we're going to use our favorite trig function for x, cosine. And then we need our theta, which is our degreed angle. And we can see it says 25 degrees. Sometimes it has the degree mark, sometimes it'll just write out the word. We need to be looking for either of those. So 25. And we leave t alone because t is going to be the variable that links the two equations together. All right, the next equation is my vertical equation, the y equals, because y is vertical movement. -16, that has all to do with gravitational pull. The t squared, again, that's the variable that links the two problems together because the time is going to be the same for both of them. We're just looking at it separately as left and right movement, up and down movement. And now VO, we already used that. The 150. Sine, because it's y. And after sine or cosine, we always put a lovely angle. And the angle here is the 25 degrees. Woo woo. T. And then plus, now this is an old school worksheet and it has YO. That 0 kind of there is initial. You can see it says initial, initial. Your initial Y value is your initial height. And it says a baseball is hit from 2 feet high. So that right there is your HO. But in this situation, it's calling it YO. So it equals your HO from your formula sheet. Okay, so this is going to be 2. Did you get the two equations? I'm hoping that you did. Now we want to talk about the tester, and I did mention this in the other video that they actually put the testers in the very beginning here. So 400 feet from home plate, that means that would be your x value here, 400 feet. And it says 8 feet high, which is kind of nice because it just quickly tells us that that's what my y is. Okay, so again, it really doesn't matter which equation that you use. I tend to use the x because it's a little bit more simplistic. In some, they'll make you kind of use the y, but then you got to watch if you can factor or if you can use quadratic formula. So because of that squared, I'm kind of like you. I want to do the more simplistic equation when it comes to actually solving the problem. It'll make it go quicker. So I'm going to take this x being 400 and I'm going to put substitute that value in. So 400 is going to equal 150, oh, I'm writing a little bigger, cosine 25. You'll see that sometimes they put parentheses around that to make sure that t is not getting cosigned because it is not an angle. We don't perform that trigonometric function on it. So now we're just going to take into our calculator and we are going to do 150 cosine of 25. I'm going to go on my calculator. 150 times cos of 25, and I should get 135.946. The directions didn't really tell me what decimal to use, so I'm going to use 3. And I know what you're telling me I'm going to do next. I can just hear you through the screen saying, if I want to solve for t, Miss Freibush, you need to divide by that 135.946 on both sides to keep it nice and balanced. You guys probably already did that while I'm writing. And you are going to tell me what the answer is. I wish. I miss you guys very much. 400 divided by 135.946 will give me a time of 2.942. But wait, there's more. T is what links the two equations together. So now I need to take that, and I'm going to do a different color. I haven't done blue yet. Let's take this right here and plug it into y to see if I indeed get my other tester of 8 feet high. Will I clear this wall and get a home run? So I'm going to take y equal to -16. My t I'm going to plug in is 2.942 because that's what we just found out with our x equation, and plugging in the 400 feet for the x value squared. Now this is negative because of the gravitational pull. So, and again, that's from the formula sheet. That's all up here from the equation that we're given. And that is really what we're doing, a lot of plugging in, substitution, which should make us feel happy because we are experts at that from all our algebra times. And now we're going to plug in t again. It's time. Oops, right here. 2.942. And then finally we add our initial height. And it is a lovely 2 here. So we go all to the calculator and do this again. So I'm going to take this first guy here and do this. Now this is going to remain negative because that 16 is not getting squared, only the 2.942. So this is going to be gravity's effect on our situation. 486 if I round it. Remember, I do these within a few decimals when I grade things. Now I'm going to take this next group of numbers and I get 186.501 plus 2. Don't forget that height that we initially started with. Every little bit of inch happens, or feet helps us get over this fence so we can get a home run. Let's see, do we get a home run? Oh my gosh. So I get 1 minus 138.486, and I get 50 Oh my goodness gracious, Miss Freibush, this might be an exaggerated problem here. The height after 2.942 seconds is not 8. It's actually, whoa, 50 feet high. So it definitely is a home run. It clears it and then some. This clearly is a very exciting problem here. So yes, it is a home run because 50.015 is way greater than the 8-foot wall. Okay, so now I am going to ask you guys to do some more problems. I have some golf problems here. I'm actually going to attach this as a worksheet on your assignments in your Google Classroom, so you guys can print this out if you want, or you could just look at the screen and write your problems on the side. So I have a few more problems for you to try, and then I'll attach another one. And if you need me to work out any of these from now on, just email me and I can make another video if you need it. And if not, I'm just going to post the answers. I have no problem doing either of them for you. I hope you all are well, and I can't wait to do another one of these soon. Stay safe. Bye-bye.